Welcome to Kyle Codes, Episode 3. Today I want to talk about learning to code. So, I know for a lot of people, learning to code is challenging because your brain is not very mathematical. It's more creative, you might call it. Oh, excuse me. So, for me, when I'm trying to understand something that I don't natively or intuitively understand, I try to make analogies between something I do understand. So let's do an analogy to simplify coding by relating it to cooking. So when coding, you're typically solving some sort of problem. There's other cases where you're just creating a user interface or styling using CSS, but a lot of the time you're running an algorithm or a series of steps to turn input data into a more useful result. You're kind of digesting data or preparing it, or it's kind of like when you're cooking, you're turning a set of ingredients into, for example, which we're going to use today, soup, chicken soup. So the problem of making chicken soup can be analogized to sorting an array or some other coding algorithm problem. So when you're cooking, the first thing you want to do is gather your ingredients. So that's step one, and that's comparative to the step in coding where you're creating data or receiving data or inputting data or asking the user to input data. They all boil down to getting data or getting ingredients for a recipe. So when you're cooking soup, usually you go to the store and you buy ingredients such as an onion, a chicken, or chicken parts, carrots, broth, or maybe you go to your garden. But the result is the same. You're getting ingredients. So in code, it's a bit easier, simpler to get your ingredients. All you do is just create them. So for example, let's say I want to create an onion. Okay, so that's how you would create an onion. Now the problem is the code natively doesn't know what an onion is. It knows what some things are, like numbers. So an integer, integer equals 3. So it natively knows what integers are because that's the computer. That's how computers think. They think in math. Integers, strings. Word. They think it's strings. They think it bits, really. Integers and strings are really a more human-readable interface in front of bits to make coding easier. But we can make it even easier because while the computer doesn't natively understand what an onion is yet, we can write our own types of objects in code. So we can create onions. And we can create chickens. So what I'm telling the computer right now is there's a class of objects known as onion. And here we're creating an instance of an onion. So the way that kind of corresponds to the real world is, say you hold an onion in your hand. Well, that's not really the idea of an onion. It's an instance of an onion. It's a onion. It's not onion. It's an onion. It's one onion out of many. Same with chickens. So let's do this. Let's create let's create classes of objects for our computer so it can understand the types of data we're going to use or require. Okay, so we've created those. Now, let's create instances of them because you can't cook an idea. You have to cook an actual instance of an object. So that's what we're doing. Now these names are pretty arbitrary. You should give them meaningful names. So onion, lowercase onion. I'm going to call it onion 1 because that kind of gives an identifier to the onion, because you could have onion 2, 3, 4, and so on. My chicken is actually going to be named Larry. Carrots don't really have names, so I'm going to call it carrot 1. Oops. New carrot. Broth can have a name. No. Okay, so I've created my ingredients. Now the next part, we have a commented code, which I've written out, and commented code doesn't get compiled and executed. It's just there so people can understand, if they're reading your code, basically what it means. So it's human readable. But it doesn't get executed. It gets removed in the compile step, I believe. Okay, so you can see these steps that we have for our recipe, which I just grabbed online somewhere. So chop up carrots, cut up onions, cut up chicken, put it in a pot, boil it, pour it out. So how do we do all this? Well, to chop up carrots, usually use a knife and a cutting board. So let's do that. Let's create a knife. There's a class of objects called knives, right? And there's a function that knives contain, or can, what would be the word? Knives can execute a function which would be called chop up or cut up. So I'm going to say chop up. There's possibly a better way to do this, but we're starting at the basics, so it's not important now. Cut up chicken, I'm going to call that slice up. So what are we cutting up? So in these parentheses, you would pass in input variables. So in a way, this is this is an algorithm called cut up, and it takes input and returns output. This one returns nothing because it's not necessary. It's going to act on a carrot. So I'm going to pass a carrot and just call it C, because that name can really be anything. And we're going to say C dot, this is our carrot, is cut equals true. For onion, O dot is chopped up equals true. For chicken, C dot is sliced up equals true. Now there's errors here because we haven't defined these. These are properties. This would be a boolean, which is just a true/false value. So a bool is a boolean value? I think that's how you spell it. It's just true or false. So we don't have, carrot does not contain a definition for is cut. So let's add that. Let's add a bool is cut. Now it can't see it still. There's an error because it's not public. So only functions inside of our carrot class. If I were to have a function here, void function name. If I were to have a function, it could talk to is cut. It could change it. It can see it. But because by default it can't, we need to add a public modifier. So now it can see it and it can set it. Good. Now, in addition to this, I'm going to set the default. When you create a carrot, it's going to be false. So when you initialize a carrot, when you create a carrot right here, it by default sets that to false. And I'm going to do the same thing for onion and chicken. Onion is going to have a public boolean is chopped up, set to false initially, chicken, public, bool is sliced up equals false. Perfect. So now we know these have state. The carrot has a state. So and just like in real life, you know if a carrot is cut up or not. Well, now in the code, you know if it's cut up or not. And to cut it up, you just change it to true. You set it. Or assign it a value. Okay. So, I want to cut up carrots. Well, this doesn't work because knife is actually an idea. It's an abstract idea. It's a class name. We need an instance of a knife. So let's create a knife. You know what? It's a rusty knife I found at Walmart. So I'm creating a knife because in code we can just create anything we want. That's the magic of coding. We're also going to chop up an onion. We're going to, unfortunately, slice up Larry a bit. Okay, everything is chopped, cut, or sliced as needed. Now, we need to put it in a pot before we can cook it, right? I don't have a pot. So how do we do this? Same with knife. Same thing we did with knife. We're going to create a new class of objects, pot, and we're going to add a function. Void. We're returning nothing. We don't need to return anything. We just need to act on the pot itself. Add ingredient, and we're going to pass an ingredient. But we don't have an ingredient yet, because an ingredient could be a carrot, it could be an onion, it could be a chicken. So we don't have that defined. That's why there's an error. So what I want to do is create a new class that basically onion will be derived from, chicken will be derived from, carrot will be derived from, and broth will be derived from. Because I want to handle all of these the same. If I'm adding chicken to the pot, it's the same as adding broth to the pot. You just pour it in, dump it in, do that. And you're going to have a list of ingredients inside of the pot. So let's create a class called ingredient. Now, this is a special class because an ingredient is an idea, sort of like an onion, but there's no abstract or there's no real representation of ingredient, right? An onion is an ingredient, but that's abstract in itself. So you don't create. You can't hold ingredient in your hand, right? I don't know if I'm explaining that well, but it's an abstract word. It doesn't really have a real world implementation, I guess. So we're going to mark it as abstract. So you can't create an ingredient because that doesn't mean anything. What does that mean? If I were to say ingredient 1 equals new ingredient, that won't work because I added that abstract keyword, and that's a good thing because this doesn't make sense. We don't want to be able to create things like that. Okay. Now, to make this a bit simpler, an onion is an ingredient. That's what that means. A chicken is an ingredient. A carrot is an ingredient. Broth is an ingredient. So each of these is an ingredient. So that also means by extension that onion 1 is an instance of an ingredient because it is an instance of an onion, which is an ingredient. So you could do something like this. Ingredient 1 equals, well, we could just set it to onion 1. Because onion 1 is an onion, which means it's an ingredient. But that's not necessary right now. So, okay, we have a pot and we have a function called add ingredient. But how do we keep track of all the ingredients that have been added? Well, let's do that by using an array of ingredients. And an array of ingredients is basically just a it's kind of like a basket with slots in it, or a pot with slots in it. So we're going to create ingredient array and call it contain ingredients. And we're going to set it to a new array of 20, a new ingredient array with size 20. So there can be 20 ingredients in there, which kind of makes sense, unless they're massive ingredients. Okay. So the way this kind of appears conceptually is contained ingredients will appear as something like this. Oh, crap. And there's 20 of these. These are slots, and they can hold an ingredient. And since an onion is an ingredient, you can have an onion in here. Now, the way we access this slot is by using the index of this particular slot, which is 0 based. So what you would do is you can access all of these by using numbers 0 to 19. Because there are 20 slots and it starts at 0, 20 is not available, right? Because 0 to 19 is 20 items. So if we were to add an ingredient to it, we would say ingredients and then index of 0 equals ingredient. Now that's going to add it to this slot only. Once this slot is full, we probably want to add it to the next slot of 1 until we get to 19, and then we don't want to add any more because it's full, right? So we need to keep track of current ingredient count. So actually this is going to be a private because people outside the class don't need to know about this, how many ingredients are in the pot. This is only for the pot itself to know. No one outside of the pot's object needs to know. It's like, who needs to know the contained ingredients in the pot? Well, actually, now that I think about it, nobody needs to know that outside of the pot. So when you call the pot, so when you're doing something like this, and this is going to be a stainless steel pot. We don't need to do anything. We don't need to know exactly what the contained ingredients are in this function. We just need to be able to add ingredients. So we're not gonna leave this public, and we're not gonna leave this public. So ingredient count, and this is gonna start at 0 because none have been added until we call add ingredient. And then what you're gonna do is instead of using 0 to index it, we're going to use the ingredient count. Because if there are 0 ingredients, you want to set the 0th element. If there's 1 ingredient, it's in the 0 slot, so you want to use the first slot, or the number 1 slot. It's not the first. This is actually the first. And then once you've put it in there, you want to add 1 to the ingredient count. So ingredient count equals ingredient count plus 1. Alternatively, you could do it shorthand and do something like this, which is the same thing as this. So I'll delete that line. Okay. Now one more thing. Before we do this, we should check if the ingredient pot, if the pot is full of ingredients. So we're going to do an if and surround this with the if statement. So if this is true, this can execute. If it's false, it'll just skip right over it and go here. It'll skip to right there. So if ingredient count is less than 20, we can add more. But if it's 20 or more, well, we can only hold 20. So you should not add any more. It'll overflow. And that would be bad. Okay, so we've created our pot, stainless steel pot dot add ingredient. We're going to add our carrot. We're going to add our onion. We're going to add broth. And we're going to add our chicken, formerly known as Larry. Where's the broth? Broth 1. That's what I called it. Okay. Now to boil, we need a source of heat, right? What should we use? A stove? Well, the computer doesn't know what a stove is, so we have to again tell it what a stove is. So kind of just going through the motions again, doing the similar things to what we did. Okay, so let's do public void heat pot to boiling. Let's just say boil pot for number of minutes, because the recipe, let's say it called for an hour of boiling. That sounds good. So you're going to pass your pot because it needs to act on the pot. It needs to use the pot in order to fulfill its purpose. And you're going to pass in an integer, which is a number of minutes to boil. Okay. So, how do we boil this? Well, the pot should probably have a state. So this is all state of the pot. Now, because the stove can act on the pot, we're going to add a new function that gives it the ability to act on the pot, because otherwise it can't really do anything. Because how does it heat the pot? There's no temperature being recorded currently. So let's start recording a temperature. Let's say set pot temperature. And you'll pass in a temperature. And we'll create state in this pot, a state item, and it's going to be temperature. Currently it's room temp. What is that? I don't even know what that is. 32? 30, sure. Let's just say it's 32 or whatever. Boiling point is 100. I don't know. I should probably look this up, but it doesn't matter. Just pretend like that's legit. Okay, set pot temperature to temp. Temperature equals temp. Okay, so in order to boil it, we need to bring it to boiling temperature. So we're going to call pot set pot temperature boiling temp 100, 230, 200. I don't know. I should know this, right? 200. I don't know if that's right. Who cares? Now we're going to wait for a number of minutes. And we could possibly do that. There's a function, well, there's a thread.sleep. This actually makes the process just, or the thread running this code just wait. So this is milliseconds. It takes milliseconds. So if we're going to wait for a number of minutes, we need to multiply that by 60 to get seconds, and then by 1,000 to get milliseconds. So we could do that. That would actually make the code run for, if I put 90 here, for 90 minutes. So we're just going to pretend like that's there, right? We're going to pretend it's boiling for 90 minutes. I'm going to comment that out so it doesn't execute. Okay, so now we've boiled. After we wait, we want to let it cool down, right? So we want to wait for it to cool down, but I'm just going to set the temperature back to room temp, which is, in my fake reality world, it's going to be 32. Okay, so pot to boil Oh, I'm sorry. Stainless steel pot. Where's the boil? No, it's a stove, so we need to create a new stove. Stove? What kind of stove? What kind of stove? Oh, Foreman. Foreman stove. And we're going to use the Foreman stove to boil our stainless steel pot. And it actually takes 90 minutes or 60 minutes or something to boil chicken soup. Maybe. Good. Now, we need to pour out the soup, but we don't have a function for that, so we'll probably have to add one on the pot. Okay. So we're going to do public. Let's say pour out chicken soup. Okay. We'll return a chicken soup. We don't have a chicken soup object yet. So let's create the goal of this entire exercise. Chicken soup object. We're going to return a chicken soup object. Okay, now this part is interesting because we put ingredients in, we boiled, but how do we know if we can pour out chicken soup? So we need to know that we put in chicken, onions, carrots, broth, and we boiled it. So let's check. Let's iterate through our ingredients. We're going to use a for loop. Int I, which is our iterator. We're going to use it as an index to grab all of the items in the array. Okay. While I is less than ingredient count. And then at the end of the loop, increment I 1. So next time around, it'll repeat and become 1. So, okay, let's create a bunch of bools. Bool has chicken equals false. Bool has carrot equals false. Bool has broth equals false. Bool has onion equals false. So we're going to go through each ingredient list. If we find a carrot, we're going to set has carrot to true. And if we get to the end of our list and we find that not all of these are true, then we haven't put all the ingredients in. We just boiled. We boiled before it was ready. We didn't even add carrots, or we didn't add chicken, or something wasn't added properly. So let's try this. If contained ingredients at index I, so we're going to grab a single list in the element, starting with 0 and then going to 1 and then 2, and then until we've reached all the ones added. If contains ingredients, okay, its ingredient is onion, has onion equals true. Else, if contained ingredients is carrot, has carrot equals true. Else, if contained ingredients is chicken, has chicken equals true. Else, if contained ingredients I is broth, has broth equals true. Okay, now here we're going to only continue to check if it's boiled if it has all the ingredients. Has chicken, and has carrot, and that's what these are, and. If you did not know that, that means and. And this is a bool value. You have to and them together. And it has broth. And it has an onion. Then we check if it's boiled. But if it does not have one of those, we're not going to return chicken soup. We're going to return null. And null is basically saying nothing. It's empty. We're not returning an actual instance of chicken soup. We're returning the void of chicken soup. There's where you hold out your hand and somebody places a bowl of chicken soup. It turns out they placed nothing. Or as soon as they place the chicken soup in your hand, it disappears. It becomes atomized and vanishes. Okay. Now, to check if it's boiled, we didn't actually add any indicator that it's boiled. So, let's do that. When you set the temperature in the pot, if you set it to temp greater than, what was it, 100? Is boiled equals true. Now we don't have an is boiled bool, so I'm going to make that because that is a state on the pot. Public bool is boiled. And it's set to false when you create the original pot. And if you empty the pot, when you pour it out, you probably want to set that to false again because it now is empty and it's going to cool pretty fast. Okay, so let's see. If is boiled, then we're good. Otherwise, we're going to turn null again because no chicken soup can be created. If we poured it out here, it wouldn't create chicken soup. It would be like slop. It would be like water, boiled water. Well, not boiled. It's not boiled. It's just mush. It's contained ingredient. It's combined ingredients that are not cooked, so you would break your teeth on them if you try to eat them. And Larry might still be alive. Good. If it is boiled, return new chicken soup object. So this is the correct code path. We want to be here. We want to ensure that all this stuff takes place. It contains all the proper ingredients, and it is properly boiled so that we can return chicken soup. So we want that. We want pour out chicken soup. So now we can go up here and say pot, stainless steel pot, pour out chicken soup. And it returns a chicken soup object. Possibly. My chicken soup equals stainless steel pot, pour out chicken soup. Okay, but before we're done, let me delete that. Before we're done, we need to see if, remember we possibly set chicken soup to null because, oh, my chicken soup. Because if my chicken soup is null, we didn't get it. We didn't get our soup. Else, it's not null. We have soup. Now you can eat it. You can freeze it. You can do anything you want with your chicken soup. So, that was kind of just a walkthrough of how to approach a certain problem, a certain coding problem, in a way that analogizes it to something that you possibly understand better, such as cooking, or maybe video games, or whatever it is that makes sense to you, whatever you already understand. So hopefully that helped. If not, I probably made you even more confused than you were before. But that's okay. Okay, bye.